Welcome to session tracking presentation of web programming course. So these are the topics that we are going to cover. First, we are going to talk about what is and why we need session tracking feature. And we'll talk about underlying mechanisms that make session tracking possible. And then we'll talk about session tracking support in servlet architecture of Java EE. And we'll look into programming APIs, and then we'll talk about session timeout and session invalidation. So what is and why session tracking? First of all, session maintains client identity and state across multiple HTTP requests for each client. So in this case, client is talking about a browser. So for client 1, there will be session object maintained for that client. So we have a session 1, and then for client number 2 for that application, there will be session object representing that client. And again, key point is across multiple HTTP requests. The client 1 will actually make a multiple HTTP request and response interchange with the application, and whatever state of the client will be maintained in the session object for that client. So why we need session tracking feature? First of all, HTTP is a stateless protocol, meaning every time a browser talks to a web server, meaning an application running on that server, it opens a new connection. And the server, as a default, or your web application, and the server does not automatically maintain a conversational state of that user. Again, the conversation here, we are talking about setup, request and response interchange between the browser and the server. So there needs to be a mechanism for maintaining this conversational state across a series of requests from the same user. Again, user, we are talking about the browser. So a good example is, again, shopping cart. So let's talk about session tracking use cases. So meaning why we need the session tracking. So when you are trying to purchase items from online shopping store like Amazon.com, you are adding an item to your shopping cart. So every time you are adding an item, that is one interchange with the server through the exchange of request and response messages. So there needs to be a mechanism, there needs to be a way of actually maintaining the items that have been added to the shopping cart. When the client decides to proceed to checkout, how does the server determine which previously created shopping carts are his or hers? So the server has to maintain multiple shopping cart objects for multiple users talking to the server. So there needs to be a way of identifying which shopping cart object belongs to which user. So these are all session tracking feature that we need. Okay, so let's talk about underlying mechanisms of session tracking. So we'll talk about the session tracking feature later on in Servlet, but before we talk about it, let's talk about what is the underlying mechanisms that are used to enable session tracking. So there are three underlying session tracking mechanisms possible. One is cookies, the second one is URL rewriting, and third scheme is hidden form fields. I want you to remember that these are just underlying mechanisms of passing session ID. So these are underlying mechanisms that make a session tracking possible. However, these underlying mechanisms do not support high-level programming APIs, and they do not provide a framework for managing sessions. So this is the reason why we need another layer on the top of these underlying session tracking mechanisms to have a session tracking possible. So that is what Servlet session tracking support provides. So let's talk about each of these underlying schemes in a bit more detail. So what is HTTP cookie? So cookie is a small amount of information or data sent by the servlet to a web browser. And browser can save this cookie in a persistent storage, and then it could actually send that cookie to the server in the subsequent HTTP request. So cookie has a name and single value and optional attributes. So you can have, in fact, a multiple name and value attributes. So you can have, in fact, multiple cookie values in HTTP cookie. So cookies value can uniquely identify a client. So cookies value, when it uniquely identify a client, it is actually called the session ID. So server, when it receive a cookie value, like a session ID that is used to identify a session, to extract relevant information about the session. So using the session ID, it will take a look at some kind of hash table is maintaining somewhere on the server to extract whatever state information maintained for that particular session, meaning for that particular user. Okay, advantages of using cookie scheme as underlying session tracking mechanism. The advantage is it's very easy to implement. It's basically HTTP header will actually send cookies in its header, and highly customizable. You can actually put into any information into. You can make you can actually put in cookies anything you want, and it persists across browser shutdowns. So even if you close the browser, next time you open the browser, it could actually read the cookies from your persistent storage, and then it will actually send the cookies to the server. So it persists across browser shutdowns, meaning when the browser is closed. Disadvantage of cookie scheme is that it cannot be used when it is turned off. So some users want to turn off cookies for privacy and security reason. In that case, cookies cannot be used as a way of maintaining, as a way of the sending session IDs. Okay, so the second scheme is URL rewriting. So URLs so what is a URL rewriting? So URLs can be rewritten or encoded to include session information. So the URL on the bottom, this is an example. Your URL could be rewritten to contain the session ID information, like a query parameter at the end. Okay. So the session ID equals like a 6688 or something like that. So advantage of URL rewriting is that it can be used when cookie is disabled, meaning when cookie scheme cannot be used, URL rewriting can be used. Disadvantages of URL rewriting is that it's kind of tedious to create URL rewriting URLs. So, and this only works when for dynamically created documents. So this URL rewriting has to be rewritten on the server-side application. Okay, so we'll see an example in a few minutes, in a second. So hidden form fields. So hidden form fields do not display in the browser, but can be sent back to the server by submit. So it's like a query parameter or form values. Okay, so fields can have identification like a session ID. So you can actually have this session ID kind of hidden inside your page. And then servlet code can actually get that data by calling request and get parameter, and that could be used as a session ID. So three different underlying schemes for basically transporting session ID between the browser and the server. Okay, so advantage of hidden form fields as a session tracking scheme is universally supported. And its disadvantages is only works for sequence of dynamically generated forms. Okay, meaning the forms has to be generated from the server. And again, it's tedious to write forms with the hidden fields. Okay, so those are three underlying schemes for transporting session ID between the browser and the server. Now let's talk about the session tracking support in Servlet. So session tracking support in Servlet is built on the top of either the cookie schemes or URL rewriting. Okay. Now, before we talk about that, let's talk about without the session tracking support in Servlet, meaning, as I said before, those underlying schemes, underlying mechanisms, cookies or URL rewriting and hidden form fields, they actually have they provide a mechanism for transporting session ID. That's it. So we need something more. So, what we need is we need to be able to generate and maintain a session ID for each session. Okay, so somebody has to generate the the session ID, and passing session ID to a servlet, either cookie or URL rewriting. So this is underlying scheme for the transportation of session ID, and there has to be a way of being able to extract the session ID information either from cookie or URL, and then creating and maintaining a hash table on the server side in which session ID and session information are stored, meaning somebody has to actually maintain all the state information of that user on the back end. And then when the session ID is received, it has to extract that state information. So somebody has to do it. So and also there has to be a way of the adding some session state information to the session object and or remove it. So basically, these kind of operations are provided by session tracking support in servlet architecture. So actually basically using cookie or URL rewriting as a way of transporting session ID, but these things are actually provided as part of the session tracking support in servlet. Okay, so this is a little bit of repeat of what I just said. So session tracking support in Servlet provides higher level API for session tracking. So it's built on the top of cookie and URL rewriting. And so Servlet container maintains internal hash table of session IDs and the state. Okay, so when it actually receives the session ID, it will extract it from the cookie or URL, and then it will use hash table that is internally maintained to extract the data state information about the server. Now, what is an object on the server in the case of servlet architecture that maintains the session information? That is in the form of HTTP session object. And again, the session tracking feature of Servlet actually generates and maintains session ID transparently. So it does generate the session ID for you, meaning you as an application developer do not have to generate session ID yourself. And it provides a simple API for adding or removing session information. They are called attributes to or from HTTP session. So it provides an API. And it also actually automatically switches to URL rewriting if cookies are unsupported or explicitly disabled. Okay, so we'll talk about that in a few minutes. All right, so let's talk about the programming APIs. So as I said before, HTTP session object is the object that maintains all the attributes, key value pair for that user. So in order to get user's existing or new session object, basically you are going to call get session method of HTTP request object, and then what you get back is HTTP session object, and then you can add attribute or remove attribute. So true means a server should create a new session object if it has not been created before. By the way, HTTP session is a Java interface, so it is the container's responsibility to create, provide an implementation class, and of course provide an object of HTTP session type. So this is an example code. So you are going to call, so this is a servlet code. Okay, so from HTTP servlet request object, you call get session method, and what you get back is HTTP session object. And then you can add or remove attribute. Okay, so HTTP session, as I said before, is a Java interface. It also contains methods to view and manipulate information about the session, such as session identifier and creation time and last access time. And it also provides methods for adding attributes or removing attributes. So basically allows a user to persist user-specific data across multiple request and response interactions. So this is the method for adding an attribute to a session object, HTTP session object. So you call it set attribute method, and you provide a name of that attribute, and then you're going to provide an object that you want to save into that session, HTTP session object. Now, in order to retrieve that the value, basically you are going to call get attribute method of HTTP session, and then you provide the key, and what you get back is, in this case, cart object. Okay, so here, this is the complete code. So here we are going to call getAttribute method, and you provide the name of that attribute, assuming it has been saved before, and what you get back is shopping cart object. And, of course, you have to actually cast it in this case. So this is the case that if cart is null, so we are trying to get the cart object, and if it is null, that means it has not been created before. Okay, so in this case, you are going to create a shopping cart object, and then you are going to save that shopping cart object with a key name as example.bookstores.cart. And later on, you could retrieve that attribute, the value of an attribute, by calling getAttribute method. Pretty straightforward. Okay, so how does Servlet support both cookie-enabled and cookie-disabled browsers? So the client meaning client browsers, could be either cookie-enabled and cookie-disabled, and of course your Servlet-based application, your backend application, should be able to support both browsers. So if cookie is turned off, then as we talked about, you have to use URL rewriting, right? Okay, so if your application makes use of session object, meaning you have to actually support the session state, okay, state for that user, you must ensure that session tracking is enabled by having the application use URL rewrite when the cookie scheme is turned off on that particular client, meaning on that particular browser. So in order to do that, for any URL that you are generating and passing to the user, you have to call encode URL method, okay, and then passing the URL object. And then it will return the URL that gets encoded, and we'll talk about what that means. So encode URL method includes a session ID in the URL. Now, only if cookies are disabled. So if cookies are enabled, then it doesn't have to add the URL rewriting at the end, meaning query parameter kind of things at the end for session ID. Okay, so let's actually see the example. Okay, so this is a method, and we'll see an example in the following slide. So basically, this method is encoding the specified URL. So you're going to specify the URL that needs to be encoded. Okay, and again, if cookie is disabled, it will include the session ID at the end. Okay, but if cookie is enabled, then it's not going to change. Okay. So implementation of this method includes the logic to determine whether session ID needs to be encoded in the URL or not. So it will determine whether the browser has enabled cookies or not. Okay, and if it is not enabled, then it will actually it will encode that URL. So for example, if the browser supports cookies or session tracking is turned off, then URL encoding is unnecessary. And by the way, for robust session tracking, you have to have all URLs emanated by the servlet should be run through this method. Okay, so you don't want actually a subset of your URLs to be URL encoded. Otherwise, for those URLs that are not encoded, and if the cookie is disabled, then the session state might not be. Well, actually, the client will not be able to actually send the session ID to the server. So this is the code. So any URL that you have to generate, you are going to call encode URL method of the URL response, and then you are basically providing your URL that you are generating. Okay, so what you're actually providing is a URL. So any URL that you are generating, you have to actually call encode URL. Okay, so this is an example that are generated URL. So if the cookies are turned off and session ID is added to the URL, this is the URL that gets generated by the encode URL method. And if cookie is turned on, then normal URL will be generated. Okay, moving forward, session timeout and invalidation. So what is a session timeout? The thing is that a user, when he's actually talking to your application, the user might actually leave without letting you know that the user, he or she, is done with your application. Okay, meaning the session state will be actually maintained until timeout. Okay, so your application should be able to take care of the fact that user will just leave your application without actually explicitly indicating that user is done with your application. So as a default, the 30 minutes of inactivity is considered that user is done with your application, and then you are going to invalidate the session. Okay. So the timeout period is server and application specific. Okay, so security sensitive application obviously will have a shorter timeout. So banking application, should not have 30 minutes timeout. It should have less than maybe 10 seconds or 15 seconds of timeout. So when there is inactivity of 10 or 15 seconds, then it should consider the user is done with that application. And the default timeout may be set by server administration. You can also set the maximum inactive interval or getting the value of maximum inactive interval through these two APIs of these two methods of HTTP session interface. So this is setting maximum inactive interval, and this is for getting maximum inactive interval. So why we need to actually invalidate a session object? The reason is because a stale session object, meaning session object that is not supposed to be there, meaning user is done, is actually taking your resources, in this case memory space. So for example, let's say we have 1,000 users and they are actually using your application 2 minutes per session time. So during the 30 minutes period, there could be in fact 15,000 users. And if you have to maintain 4K bytes of data for that particular session, for that particular user, you're talking about 4K times 15,000 users, and you're talking about 60 megabytes of memory is needed just for that one web application. And that's a lot of memory space that needs to be maintained, right? So it could have a performance impact, okay? And another problem, of course, is a fault tolerance. Okay, so so what we need is that we need to actually free up the memory space as soon as the session is done, meaning as soon as the user is done with your application. Okay, and so this session invalidation could be used by the servlet programmer to end the session proactively. Now, so you could design your application so that the session will be invalidated, meaning close the session through the business logic flow. So when like a checkout page in the checkout page in your shopping cart application should be considered as end of a session. Okay, so in that case, you are going to invalidate the session. So you're going to free up all the memory space that is maintained, that is actually used by the session. Or you might in fact provide the log out button in your application page so that user can click log out button. That is an indication that the user is done with the application. Okay. So the way that you are going to invalidate, meaning close the session, is calling invalidate method. Okay. So basically calling invalidate to a session means I'm done with the session. So all the resources that are being used by the session should be released. Okay, so this is the way that you are going to invalidate session. Okay, so suppose this is the checkout logic and everything is done, then you're going to call invalidate method of the session, then resource will be released. Event handler. So every time any session object is unbound, meaning the session is done, then it will be this is actually this is a value bound and unbound. So this is the example code. This is the method that could be invoked as a callback function. So whenever a value is removed, you can actually get this callback method. Whenever value is added to the session object, you can actually have a callback method. So you can actually do some kind of logging scheme or performance tracking scheme or whatever. All right, so that's the end of the presentation. Now let's take a look at the hands-on lab. So the first hands-on lab is exercising cookie schemes. So in this scheme, so this is the servlet examples. So we are going to execute cookies. So execute cookies here, and you are basically adding key value pairs as cookie values. Okay, so when you submit, it is going to be sent as cookie values, and then it will be maintained, and it will be returned from the server as well. So you can just kind of display things. Okay. And you can actually take a look at the cookie values. Okay, so you can click cookies and you can actually see the cookies. So if you're actually using HTTP monitor scheme of NetBeans, or you can also use web developer or web console of your Firefox browser, and you should be able to see the cookies information that are being sent from the browser and to the server. So this is the case. This is the send cookies, meaning the cookies that is already in the cookies array, and this is the new cookies. Okay, so let's take a look at the code. Let's run the application first. Okay, and that is Servlet examples. So here, this is the cookies. So these are the cookies that have been already set. Okay, so now cookies. I'll just say my name Sang Shin is value is 100 years old, something like that, and submit cookies. And so this is actually sent to the cookies, and as long as in this session, I'm gonna actually being able to actually retrieve those cookie values. Okay, so that's an example. And again, if you actually see, so let's take a look at the web developer and web console. So here I'm going to select net. Okay, so let me actually run another one. Y equals 2 or something like that. Okay, here we go. So you can see now the cookies. Cookies is this is the set cookies headers. So it's actually cookie headers and actually sending it. Okay. All right. That is exercise 1, relatively straightforward, and the code is very simple. So you should be able to call get cookies method from your HTTP request, and then all the cookies will be retrieved, and you can do anything you want. Here we are just displaying it. Okay, and whenever new cookie is arrived, we are going to so when the values are being sent from the server as a request parameter, we're just adding it as a cookie. Okay, so that's the logic of this application. Okay, exercise 2 is this is the JSP examples, and here you're going to run it, and then this is the shopping cart example. So let's run this application. So this is the JSP example, shopping cart example here. Cart, execute. So these are the books. So I can just choose any books, and this is actually maintained in the session. So waiting for this request. So now it's added in the shopping cart, and then I can add another one. And so basically, this application is displaying all the items that are being maintained in the session object. Okay, so shopping cart object is actually an attribute inside this HTTP session object. Okay, so let's take a look at the code. Yeah, in this example, you're actually making a breakpoint and to see whether shopping cart object is maintaining all the old the items that have been added. Okay, so something that you can try. So let's take a look at the code. So here we are using the cart, the Java bean, and you can see the scope is a session. Okay. And if you in fact change that to request, then it will not be maintained every time you are going to add an item, because it's not the HTTP session object, it's a request object. So every new request will actually start from scratch, so nothing will be saved. Okay, so that's basically application. Same thing. Application is larger scope than sessions. So this one, in fact, the whoever actually adds item, you could have multiple users adding items to the cart. In that case, all the items already added by all users will be in the same object. Of course, that's not the one you want, right? Okay, so typically you want to have a session object per each user. All right, so that is the end of this presentation. Thank you.